Morning algebra. Sorry I can't be with you today, but I'll be back Monday and we'll pick up where we're leaving off today. So this is going to be a new lesson. Really, it's not much different than I would do if I were there with you live today. I think we'll be okay learning this new material this way. But if you have troubles, it'll be okay. I'll be back Monday and we'll fix it. But you guys got this. So we're doing lesson 7-6 today, and we're continuing moving towards the point that we'll be solving trinomial equations. Right now, we're still just in the factoring stage of that. Very quickly, we will be moving into material where we'll solve the equations. But today, we're going to look at factoring trinomials in the form of ax squared plus bx plus c. And you'll notice that now we have a whole number leading coefficient, or an integer leading coefficient. So it can be positive or negative. I think most of them are going to be positive today. We'll see. But anyway, that's what's different as compared to the last lesson that we did, where it was just x squared plus bx plus c. So our leading coefficient was always a positive 1. Now we're going to throw some other numbers in here, and that's going to change the way that our binomials end up looking when we factor this trinomial into its parts. So we are going to identify the common factors in the coefficients of the terms of the trinomial expression, and we're going to write a quadratic trinomial as a product of two binomial factors. Very exciting stuff. Okay, so let's jump into it with kind of the warm-up question here that they give us. Website design company resizes rectangular photos so they fit on the screens of various devices. What expression represents the width of the photo? So we have the area of the photo given as x squared plus 7x plus 12, and they give us one dimension of the photo, but they don't give us the other dimension. And so we need to figure out what the other dimension is. Well, if this is the area, we know we get area by doing length times width. So they've given us one of the dimensions. We need to figure out what the other dimension is, and that would be the other factor. So really all we need to do is factor this, which means remember that when we're factoring trinomials in this form, we just need to find the factors of 12 that multiply then to 12 but add to 7. So the first thing I would do is write the list of factors of 12, which would be 1 and 12 and 2 and 6 and 3 and 4, and that would be it. So I can see that the two numbers that multiply to 12 and add to 7 would be 3 and 4. And so that means then that my factors are, x plus 3 and x plus 4. So they had already given me x plus 4 as one of my factors, or one of the dimensions of the photo, and now I can see that the other dimension needs to be x plus 3. And then they want us to do this. It says part B here, and this is just to get us to thinking about what we would do with a scenario like this. Write 3 possible lengths and corresponding widths of the photo by substituting different values for x. Well, I can substitute values in for x all day long and come up with lots of different sizes for this photo or whatever. And so, then we could just, whatever number we choose for x is fine. So I can choose numbers like, x equals 4. So that would mean 4 plus 3 times 4 plus 4, which would just be 7 times 8, right? And then, not 7 times 8, 7 plus 8. So 7 plus 8, which would be, times 8. I had it right first time. Sorry, I'm doing this late at night. All right, 7 times 8, which would be 56 units squared, whatever the units are. And so we could do that with other numbers. We could say x equals 5. We could say x equals 10. We can just choose 3 numbers for x. We can plug it into our equation, and then, and there you go. Okay. So that would be one way of kind of meeting the requirements of Part B here. Let's see, what happens if I put x equals 4 into this equation? I wonder what's going to happen if I do 4 squared plus 7 times 4 plus 12. Well, 4 squared is 16 plus 28 plus 12, and 16 plus 12 would be 28, and 28 plus 28 is 56. What? 56 there and 56 here. Is that a surprise that when I plug the same value in for x into those two equations that they come out the same? It shouldn't be, because we know that they really are the same expression. And so that's Part B, just to see that we can actually use real numbers to come up with real measurements for the photo in this scenario. And then the reason we do that is just to kind of help us answer Part C here, which is, why would the company use an expression to represent the area in the first place? Why not just tell us what the numbers are? Well, the point is that whatever numbers we plug in for x are going to keep the photo in the correct proportions, so they can make small brochures, they can make large posters, they can do even giant murals or something that fit the proportions of the photo, and all they got to do is substitute various numbers in for x, and they can keep their photos exactly the way they want them, proportionally speaking. Okay, so here we go. That was a good warm-up to get us started, reminding us how to factor these trinomial expressions that were in the basic form that we've already looked at. Now, and I've thrown a couple of extra slides into my notes here, just 2, I think, one here and then one at the end, that I had already printed the notes that you have, so just bear with me here. I just wanted to do this by way of reminder of what we've done. We typically have been foiling this, where we just multiply first outside, inside, and last. But I wanted to remind you also that along the way we had learned this, what we call the box method, or the table method of factoring, not of factoring, but of multiplying these binomials. And so when we did it with this box method, we did this 3x plus 2, and then 5x minus 8. And we just multiplied it kind of in a matrix form here. 5x times 3x is 15x squared. And then 5x times 2 is a plus 10x. And then 3x times a negative 8 would be minus 24x. And then a negative 8 times a plus 2 would be minus 16. And then it was these two terms here that simplified. So that should have been squared. I didn't do that. 3x times 5x, 15x squared. So it's 15x squared minus 14x minus 16. And so this box or table method was very handy for us, multiplying some of these expressions so that we could find our final trinomials. And the reason I wanted to refresh our memory on this is because this is the method we're going to use today to work our way backwards. When we start with the trinomial and we want to work our way back to what are the binomial factors, this box method is very, very handy for us to use. Okay, and that's where we're going here pretty quick. Not quite next, I guess. We're going to start off with some basic factoring at first. What is the factored form of 3x cubed plus 15x squared minus 18x? Well, the first thing that I need to notice is this is not kind of the way our standard trinomials looked. We usually had a squared term here, we had a single x term here, and then no x term here. Well, we need to factor this. We need to do a step of factoring here that goes before we factor into our binomials. And the way that looks is this. Each of these terms shares a common factor. That common factor is 3x. So I can actually factor out a 3x. And then what is 3x cubed divided by 3x? Well, that would just be x squared. 3x times x squared is 3x cubed. Okay, and then do that with the next term. So what is 15x squared divided by 3x? Well, that would be plus 5x. And 3x times 5x is 15x squared. So that's how that factor works. And then how many times does 3x go into negative 18x? Well, that would be negative 6 times, minus 6. 3x times a minus 6 is negative 18x. So now I've factored out a term, and this needs to remain one of my factors, but now I have a trinomial that I can factor even further. I really couldn't do much else with this trinomial until I factored out this 3x. Now that I've factored out the 3x, now I can go into this trinomial and I can factor it again. So we start here, excuse me, we start here with our negative 6. What are my factors of 6? Well, I need the numbers that multiply to 6, so 1 and 6 or 2 and 3. And then since this number is negative, one of these has to be negative and one of them has to be positive. And I need those to add up to a positive 5. So I can't do that with the 2 and 3, but I can do it with 1 and the 6. If I have a positive 6 and I have a negative 1, that multiplies to negative 6, and then positive 6 minus 1 would be 5. So those are my numbers I need to work with. So I still have to keep the 3x. And then I'm also going to have an x minus 1 and an x plus 6. Okay? So this is the factored form of my original trinomial. That's the way this works. It's just one added extra little step compared to what we've just been doing, which was factoring these guys. Now we've got to factor a number out of it first before we can do the factoring we're used to. Okay, here we go. So for this example, 5x squared plus minus 35x plus 50, what is the common term that we can factor out of each of those terms of the trinomial? Well, we can factor out a 5. So it's 5 times x squared minus 7x plus 10. And now I can factor this. So I need numbers that multiply to 10 and add to negative 7. So since this is positive and this is negative, they both need to be negative factors. So negative 1 and negative 10 multiply to positive 10, or negative 2 and negative 5 multiply to positive 10. But it's negative 2 and negative 5 that add to negative 7. So we would do 5 times x minus 5 and x minus 10. Okay? And then this one here, we can factor out a 6x, and that would be 6 times 6x times x squared, and then 30x squared divided by 6 would be 5x, and then 24x divided by 6x would be 4x. And now I can factor this. I need two numbers that multiply to 4 and add to 5. Well, that'd be 1 and 4. So 6x times x plus 1 times x plus 4. So 1 times 4 is 4, and 1 plus 4 is 5. Okay? Whoops. All right. If ax squared plus bx plus c is the product of binomials, how are the values of a, b, and c related? Well, we know how they're related because we've done this already a bunch of times. We know how to FOIL this. We know how to use a box method or table method to multiply it. We looked at an area method of multiplying, so we know that there are relationships between these values. So if I do the FOIL, 3 times 2x, 3x times 2x would be 6x squared. So that two first terms would always multiply by each other to give you the coefficient in front of the x squared. And then the 3x times 1 that's there. And then you have a 4 times a 2x, so that's plus 8x. And then you have 4 times a plus 1. All right. And now I can simplify that. So 6x squared plus 11x plus 4. Okay. And we see some patterns here, and they do this a little bit differently in the book. They have a kind of an algorithm that they bring in for factoring these that are, I think, a little more complicated. In fact, one of the two methods that they ask you to use is a method called substitution, and it takes about 5 or 6 steps to get through the substitution method. So in your assignment, when it says to factor by substitution, just factor it the way that we're learning it today. I don't care what method of factoring you use. I'm trying to teach you kind of the simplest way that I know how to do it. And as we move forward, we'll look at some other ways of doing it. But for today, we're just going to use this box method because I believe it is the simplest. So we want to see the relationship that these have. And the key relationship is this. If you'll notice these factors, 3 times 4 is 12, 12 times 2 is 24, 24 times 1 is 24. Well, look what you get when you multiply 6 times 4. 6 times 4 equals 24. So if I multiply all of the factors that I've got here, then I get 3 times 4 times 2 times 1 equals 24. Okay, and that's going to be a key number or a key thing that we need to look for as we move forward. Okay, so we want to kind of find that relationship. We're going to see that how that works as we move forward into factoring. Remember, it was this one and this one that multiplied to give us the number that we're trying to work with. And so my A term times my C term is what I want to do. 10 times 3. A times C is 10 times, in this case, is 10 times 3. And we're going to use this box method here. And I'm going to put my A term here, 10x squared, and my plus 3 here. That's my C term. And if you remember when we're filling out that box, it's those two middle terms that combine, that add together to give us this term. So we just need to figure out how to break 17 into pieces that can go into these two boxes. And then we can work backwards from there to find our binomials. So I need two numbers, or I need 10 times 3 is 30, and I need to know the factors of 30 that multiply to 30 and add to 17. And so factors of 30 are 1 and 30. 2 and 15, 3 and 10, 5 and 6, right? Well, the two of these that I need are these two right here, 2 and 15. And so those were the two numbers that were in these two boxes that added up to be 17. It has to be those two numbers because they're the only ones that fit. And so I can put a plus 2x and plus 15x. And it doesn't matter. I could have put 15x here and 2x here and it would have worked just fine. Okay, so don't get worried about which box those go in. They just go in the two boxes. And now I can work backwards from here, and all I have to do is factor out common terms from each of these items in the box, kind of in that matrix method that we look at when we're multiplying. So what are my common factors of 10x squared and 15x? Well, 5 goes into 10x squared, and 5 goes into 15x squared, so it's going to be a 5x that goes into both of those. Common factor with 2x and 3, well, the only common factor they share is 1, so plus 1. Since this is a plus here, that needs to be a plus. And then common factors of 10x squared and 2x would be 2x. And the common factors of 15 and 3 would be 3, so plus 3. So those are my binomials. That's where I need to start with. So 5x plus 1 and 2x plus 3. So if we were to, I'm not going to make you do this. You don't have to FOIL these and work it back again. But just to show you, 5x plus times 2x is 10x squared. And then 5x times plus 3 is plus 15x. 1 times 2x is plus 2x. And 1 times 3 is plus 3. So simplify the two middle terms. It's 10x squared plus 17x plus 3. And that's where I started. That checks with this right here. And so that's our box method or table method of factoring. Okay, so let's do this one. I've got my A term and my C term. So I multiply those two. I put those in the boxes first, I guess. 2x squared. Then I've got a minus 21. So 2 times negative 21 is negative 42. So I need the factors of negative 42. Two numbers that multiply to negative 42 and add to positive 1. Since B here is 1. There's a 1 in front of that x. Okay. So 1 and 42 doesn't do it. 2 and 21 doesn't do it. 3 and 14, 4, 5, 6, 6 and 7. Okay, so 6 times 7 gives me 42. And then I just need to decide which one of these two needs to be positive and which one needs to be negative. Since this number is negative, it has to multiply to a negative, which means one of them is positive and one of them is negative. Well, this needs to be positive, so I need a plus 7 or a positive 7 and a negative 6. Negative 6 times positive 7 would be negative 42. So, and again, it doesn't matter which one of these boxes I put this in, but I'm going to have a minus 6x and I'm going to have a plus 7x. Okay? So common factors of 2x squared and 7x. The only common factors would be x. And then common factors of negative 6x and negative 21 would be minus 3. 3 goes into 6 and into 21. Common factors of 2x squared and negative 6x would be 2x. And then common factors of a positive 7 and a negative 21 would be 7. Since this part is positive, that needs to be a positive. Here, this is negative because this is negative. Okay? So x minus 3 times 2x plus 7. Those are my two factors, my two binomial factors. All right. let's just roll through a couple more of these just to get used to doing this factoring. So 3 times negative 8 is negative 24. That's going to be the number that I need to factor. So 3x squared minus, oops, put it in the wrong place, minus 8. So I need two numbers that multiply to negative 8 and add to negative 2. So that would be 1 and negative 8. Well, hold on just a second. Getting ahead of myself. 1 and 8, 2 and 4, and that's it. So it's got to be the 2 and the 4. Sorry, I botched it. I told you guys it's late when I'm recording this, and I'm already getting groggy. I needed to multiply these two numbers. 3 and 8 is 24. Hopefully you caught that mistake that I was making. I don't know why I was trying to just factor 8. So 3 times 8 is negative 24. So I'm factoring negative 24. There we go. That feels better. Sorry about that. As always, I hate making mistakes just because I know it confuses you guys. So 1 and 24. I keep wanting to put negative signs on there. So 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So what two numbers can multiply to negative 24 and add to negative 2? Well, I can have a negative 6 and a positive 4. Negative 6 and a positive 4 would do that. So minus 6x and plus 4x. Common factors of 3x squared and 4x would be x squared. Common factors of negative 6 and negative 8 would be negative 2. Common factors of 3x squared and negative 6x would be 3x. And then 4x minus 8, the common factors would be plus 4. So my two factors are x squared minus 7 and 3x plus 4. All right, just a couple more slides. Just trying to get more practice. So 2x squared minus x minus 6. Build my box here. My boxes are getting sloppier and sloppier. So 2x squared minus 6, and I'm going to multiply. 2 times negative 6 is negative 12. So I'm factoring negative 12. And again, with the negative signs. 1 and 12, 2 and 6, 3 and 4. So if I have a negative 4 and a positive 3x, or a positive 3, that would give me a negative 1. Negative 4 and a positive 3. So negative 4x and a positive 3x. Common factors of 2x squared and 3x would be x. Negative 4 and negative 6 would be negative 2x. Since this is negative, that has to be negative. And that shouldn't have an x on it. Negative 2, there we go. 2x squared and negative 4 would be 2x. And then common factors of 3 and negative 6 would be plus 3. So x minus 2 times 2x plus 3. All right, almost the last one here. I've got one more example that is not in your notes, but just one more to go through after this. 10 times negative 1. So we are factoring negative 10. (10x squared minus 1). And factors of 10 are that multiply to 10 and add to 3. So it would be 1 and 10, 2 and 5. That's a tough one. So positive 5, negative 2. So negative 2x and positive 5x. Common factors of 10x squared and 5x would be 5x. Minus 2 and negative 1 would be minus 1. 10x squared minus 2x, that common factor would be 5x. And then positive 5x and a negative 1, it's just going to be a plus 1. So 5x minus 1 times 5x plus 1. Okay then. I knew something was wrong. You guys are letting me make mistakes. Who caught it? How many of you caught the mistake? Raise your hand. All right. This is not 5x plus 1. Common factors of 10x and 2x would be 2x, not 5x. So that should be 2x plus 1. That one is 5x. Okay. Mercy, sorry about that. Okay. Last one. Sometimes, this should have had a squared there, sorry. Sometimes we'll need to kind of combine the two things that we learned in this lesson. So we learned, and that's just not even right. Good grief. Let me correct this real quick. I'm glad it's not in your notes because it's just not right. This should be squared. And this should be 36. Okay, that's going to work better. I have this worked out on a note card here, but I had it written out correctly, but I didn't type it correctly. Okay, so sometimes we need to combine the two things that we've learned. And the first step that we learned was to factor out common factors before we even start the process of finding the binomial. We just factor out any common numbers that are there. So when they all have x's like this, that's kind of a clue for us that we need to do some factoring at the front end. So the number that will go into 36, 21, and 30 is 3. So I can factor out a 3x out of my entire trinomial. And that would leave me with 12x squared plus 7x minus 10. Right? Yes. Okay, so then I can do my box method. And we're going to get into a little bigger numbers here this time, but that's okay. So 12x squared and a minus 10. So I need to factor 12 times 10 is negative 120. That's what I'm factoring, okay? So obviously 120, 1 and 120, 2 and 60, I mean, those are all factors, but I mean, I've got to get only plus 7 here, so I need to get factors that are closer together. So 3 and 40, you know, I guess that's okay. 4 and 30, we're getting closer. 5 and 24, getting closer still. 6 and 20. That doesn't get it. 8 would be 8 and 15. There we go. That'll do it. So 8 and 15 are two numbers that multiply to 120 and add to 7, or negative 120 and add to 7. So I need a plus 15 and a negative 8, or minus 8. So minus 8x and a plus 15x. So now I can factor this, 12x squared and 15x, common factor is 3x, negative 8x and negative 10, the common factor is negative 2, and then 12x squared and 8x, the common factor would be 4x, and 15x and minus 10, the common factor is 5. So I need to have 3x times 3x minus 2 times 4x plus 5. So this adds an extra step in here where you have to factor out the first term and then build your box and figure out your binomial. Okay, sorry for the mistakes in there. I know I made several of them. Hopefully they didn't throw you off too bad. There will be an assignment, and we can go over things Monday. We'll spend at least one more day on this before we move into other stuff. Remember, we got state testing Monday. I think your English classes are going first Monday, Tuesday, and then math is Wednesday, Thursday. But come to First Hour with your Chromebook charged and ready to go. See you on Monday.